To solve the evidence, I used the formulary. The first problem, I used the density, mass and volume. We need to get the mass, so I made this formula right here, and this was the mass that I get. For the specific weight, I used the mass per gravity equals to the specific weight. For the second problem, I get height, density and gravity. I use the formula of pressure is equal to density per gravity per height, and this was the pressure. So for this pressure I substituted in here with this equation, and I substituted this for this, that it was the area, and I get this. For the third, I get the two areas and use this formula. Force is equal to mass per gravity, and I substitute it and I get this. So then I use this formula, leave along the force 2 and get this, and this was the resultant. For the fourth, I get also the two areas, but this time they ask me for the pressure. So for the pressure I use the formula of force between area, that is, it was this. And forget the force, or the first force, I use this formula and I get this. In the fifth one, I get the density of air, volume of the balloon, density of helium, and the weight, that it would be like the force that goes down. I need to get the mass, so I use the formula of force between gravity. It was equal to 9.582. I get the difference between the density of air and density of helium, and this was 0.722 kilograms per cubic. And doing the math, or multiplying 0.722 kilograms per 20 meters cubic minus 9.58, that was this one, I get the mass, that it was 4.86 kilograms. For the sixth one, we used something like that, but this time we had the radius of the balloon, had the density of the air and the volume. So this time I used the formula of V minus force of gravity between gravity. First things first, to get B, I had to multiply the density of the air per the gravity per the volume, that it was the resultant of this, and this get me the B. So I substituted in this formula, that was this one minus 490.5 between 90.1. This number was the force of gravity because it was 50 per 9.81. And doing the math, I get this little number, For the seventh one, we have area, velocity and liters. So the formula was Q equals to velocity per area, that was this right here. So to transform this little number into liters, we have to multiply this per and then divide the resultant of these two and get 225 liters per minute. To get the time, we had to get rid of the liters, so dividing it get eliminated. Division get 0.0888 minutes. In the eighth one, we had the height and the area. To get the velocity, we had to do the formula, the square root of 2 per 98.1 per 5, that equal this. So to get the Q, we have already velocity with this one. To get the area, we had to divide 20 millimeters between 1000 squared, and gave me 2 per 10 minus 0.3, and gave me this result. And for the last exercise, we have radius, that was 50 millimeters, height 4 meters, and we need to calculate the velocity that the water is going out of the hole. So to get the velocity, we had to make the formula that we made minutes before, and gave me 8.8588 meters per second. That was the velocity. So to get the area, we had to pass 50 millimeters to meters, that was 0.05 meters, and then we had to make the area formula to get the area. With this, we substituted in this formula, and to get the seconds in 5 minutes, we made a table of 3, and multiplying all this, it gave me this.